Here we go. So now I will share the screen. Okay. Okay, so let me show you. So in the Mosa server, you can find this all the files that we will use here. Here's the tutorial. And here is the Waywatch model that we want to use. So we're basically, the first part of this tutorial is basically the same as yesterday, where we just create an environment, copy the files. So, for example, the work.dir file, that is the big one, is the same. So you don't have to choose, you have to copy it again. There has been some modifications to the Benguela home file. So please remove that directory and copy that again to make sure that everything works. This should work. So okay, you need to copy this file from this site. Is small, so it won't be a problem. You have to unzip the files and expand all the directories and files. And as it was mentioned before, the scripts are very generic, so we don't have to do too many changes for this. Remember one of the important changes is the run environment. So once you extract everything, make sure that you edit that file. The key parts are one, this is the same, this is new in the file, but you just adding the netcf libraries. The key parts that you have to put your own, you have to change this for your student number, your account number. Those were the key parts in the previous section. And the other key part we have to do now is to define the correct location of the Waywatch model. In this case, we will download the model and install it in a directory called Waywatch tree, and we'll expand as that. So this is an important step that here you have to change your account information. And the rest, I think, is more or less the same. So this was mentioned before, no? In the previous section. And now we take a look at this directory, which we watch 3 files in the work directory, work configs Benguela, and we can also look at the Waywatch in files. So let's look at that. So under home configs Benguela, we have a Waywatch tree directory where you have this script to compile the Waywatch code. That is adapted to this environment. And in the subdirectory inputs, we will have some of the key configuration files for WaveWatch, for those who have used this model, basically the switch file, and where basically we select the physics we want to use. This is not unlike WRF. We have to compile the code as in CROCO every time we change the physics. And the input files for wind, the grid, etc. And the shell, this is the input file for the actual run of the WaveWatch model. So we see in this case, let's look at the switch ocean wave Benguela. As Sven was mentioning this morning, all these very compact three-letter instructions have a very precise numerical meaning, or is the way you select the physics you're going to use. So it's very nice to try to do couple ocean atmosphere wave model, but keep in mind you have to become expert in each of these models in order to run this simulation in a correct way. So this is a key component of a WaveWatch simulation. So if you want to understand how someone did a simulation, you may want to look at the switch file they used. And the other one is this WaveWatch 3 shell input base ocean wave. And here's the information that it will be used for. And this will be replaced by the script, and it will be used later when WaveWatch is running. And okay, so these are the base scripts. And as it was mentioned, you have to change the couple home, couple work there, and the correct location of the export WaveWatch. This should be lowercase. Okay, we are not going to compile the code in this demonstration because it takes time and we just code compilation. What you need to know when you compile the code for CROCO, you need to make sure that the cppdevs.h, the file that contains the equations of the model, you have ocean wave coupling and this wave core interaction method by the initial of the authors of the paper, McWilliams, Restrepo, and L. And that. Okay, so this is the standard. Those are the standard steps for compiling CROCO in this environment. And the executable file, we want to name it CROCO Ocean Wave to make sure that we don't use a CROCO file that a CROCO executable is not compiled with that. To compile the WaveWatch code, what you need to do is, if you want to do it, is download this file. It's small, so it will be not too much of a problem. You go to your root directory, and there's where you uncompress and you tar the file. You extract the file. That will put everything in a directory called like this. We will put everything here. Yeah, and for example, in this directory. You have the files that you need to create. For completion. So in this case, normally the Excel directory is where the files are stored. In this case, our pre-compiled files are in this directory. So we have the boundary conditions, the output, and basically the shell. And this is the one that runs the model. All these are for pre or post processing of WaveWatch results. This is for the initial condition, for example. But this is the one that will be running the model. And here's the switch that was used to compile this executable file. So those who don't know, for WaveWatch, the switch is one of the key files. And after that, okay, so we just go to Benguela, home, configs, Benguela. And we run here the run couple ocean wave script. So this script, what we will do is to create a output directory in Benguela work there, where all the input files and all the configuration files are going to be copied, the executable files, and that's the directory where the results will be stored. For some reason, and this script copies the information there and then launches the model, the simulation. For some reason, it's not doing the last part. It's not doing the launching the simulation. So we're going to use do it in 2 steps. So if you run this script, it will start copying the things to work there, configs Benguela. It also creates the files for Oasis and creates the input files for WaveWatch. For example, here's the grid, here's the wind, etc. So now we go to this directory. It's going to be outputs coupled ocean wave. And here are all the files for so we have files for CROCO. Oh, it run the simulation. Seems maybe it did it, but I don't know why it was so fast. Oh, it was really fast. Seems to be it actually did it. Okay. So we have an average file that was created now and a his file that was created now. But if you're not sure like me, you can go here and do. Let me see. You can do batch, or you want to launch it again. You launch at the end the previous script at some point launches the simulation with this command. So you want to do this command by hand, you have to do this. And the launch command is like the one we were using, the run NLHPC for the previous week. And biochemistry part, where we're using the servers for the reserved the computing nodes, and we're running the simulation in 20 cores using this script or configuration. And this configuration says that you will launch WaveWatch with 16 cores and CROCO with 4 cores. So let's do it again. Just why not? So now we can see all the output, the information exchange. I think it's done. There's no more. There's no work. There's no simulation working being computed. So if I now do let's BF so I can do NC dump. So let's see this. CROCO his. Yeah, it was calculated now. The previous his was saved as at 26. So this is like an instant simulation. Minus H. Okay, I missed this. So the his has 73 steps, and the average file has 72. So let's do now purge, and now we view oh, come on, how do I load NC view? Okay, this is module spider, NC view. This is to check how do I correctly load this module. So, okay. Vamos a ver. And then okay, now CROCO. And you have here your variables. So here we selected these variables. Well, temperature. I don't know if this will be very important. But you can see the other variables. This is the one that was mentioned, the figure that is mentioned here, the 3D Stokes drift velocity. So it's in meters per second. So this goes up to 4 centimeters per second, max values in this case. And let's see if the average file is wrong, like the other tutorial. Temperature. Yeah, so there's something. So don't look at the average files, just look at the his files. So you have this. Remember that in CROCO.in, you define what are you going to save. So you have the standard fields for the oceanography part, but you also have this history. You have to these fields in this. And okay, I understand now why I was missing information, because these are the 4-dimensional fields, that is 3 dimensions in space plus 1 in time, 3 plus 1. But here you have the 4-dimensional other variables. Oh, this is all 0, but anyways, this is surface plus time. Okay, so this is for the CROCO simulation with coupled with WaveWatch. The executable here is CROCO X, and the executable for WaveWatch is called WaveWatch here. Remember, this is a couple simulation. So what OASIS is using to understanding to combine these models is this file, the NumCop. It is the key file for this case. What you exchange, what is being exchanged, how often you exchange, etc. So it's fast and it's well cooked, and we need a special summer school in ocean atmosphere coupling to really go into details and change domains and do experiments. But at least we can show you that it works, and there are a lot of scripts that can help you to create your own setup. And the other thing that it was mentioned at the end of the previous week, and now Rashid made a good presentation on this, is the case of the idealized case that are in CROCO. And for this, the suggestion is for you to follow this tutorial that is part of the CROCO documentation, where you can see several examples that are related to what is literal dynamics. So you can see in this what is the configuration, for example, In this case, we're look at the scales we have to deal in these situations. You have, I don't know, but I don't know the dimension of the matrix, but this looks like 200 by 200, around that. But we're dealing with depths from 1 to 6 meters and 500 by 700 meters, 800 more or less, 600, 500 by 800. So it's a very small domain. And here's all the description of the pre-processing option, the CPP depths. And here also you can find the articles that relate to this. Okay. So this is for what can be done. Now let's stop this.